Popping up. All right, we're live. Happy Monday, everybody. How's the team doing?
Good. Very well, thank you.
Excellent, great. We picking up on where we were last week and really the last couple of weeks. We've been looking at the sorbent chamber for Epiphyte, and trying to think of ways to solve some of the key problems like airflow and you guys know them. And I was in LA on Friday for a couple of events, which was amazing. I was the MC for the carbon capture module launch, which was extraordinary. But then at the end of the day, I got to drop by Clarity Technologies, also based in LA, which is an earlier stage startup. One of their members, their chief scientist, Kirsch, has been working on some of our advocacy stuff in California. But when I was there, and I don't have a picture of it, they have a miniature DAC machine that they use for testing that looks almost exactly like ours, but is a bit fancier. It has the exact same shape, the same thing, and all that. And we started talking, and I was mentioning some of the challenges we have around our sorbent chamber. And then he opened up a door and he pulled out a little cube that was a ceramic honeycomb brick. And then he proceeded to explain to me how they quite, relatively simply within their environment are able to use that. I'll show you in a picture to basically embed sorbent into and allow air to flow through. So I shared some information with you guys on the Discord on Saturday, just to kind of get your thoughts on it. And it seemed like people were intrigued. Ling, you said you were. David, you just said. So I thought since this was what we were doing last week, we might want to explore that a little bit further. And the questions that we might have that we could bring back to Kirsch for some further assistance. Sound good? Cool. Any other updates on your side, guys, before I screen share a bit, or anything else we want to discuss?
No.
All right, cool. So let me share a basic picture of what I was just describing, which is here. So this is the other thing that was cool is they have they have particular dimensions that they need, so they have these custom made, but what you're looking at there is not very different from what he showed me, and that's actually an off-the-shelf catalytic converter filter. So these are on the market in various different shapes and sizes, and they cost between $5 and $12 at the places I was looking at. So, but based on what I described, I'm just curious initial questions you guys might have. There's obviously a few steps to this, but I was thinking as I shared this picture, maybe the square that we already have, there's a way that we could kind of insert either a long cube or do something that is wider, and narrower. But anyway, that's the basic idea. So curious if you guys have any initial thoughts or questions.
Well, I'm just thinking initially that if that thing goes in place of the sorbent, and it's smaller than the way the chamber fans out, there's no reason the chamber needs to be any wider than this monolith.
Yeah, exactly. I mean, I asked them a question about, obviously the way we packed it in there before, raw. If you do something like this where it's more dispersed, that the capture, per area is going to go down. And he said, yeah, that is the case, but we have some room to play with, as we already know, where we could get a honeycomb that's a certain thickness and a maximum width, I guess, to maybe balance that. But you were saying, David, just to summarize what you said, you were pretty much saying there's no reason probably why we couldn't, with some sort of tweaks, fit this inside our existing system. Is that kind of what you were getting at?
Well, I'm just thinking maybe we don't need a system that's as wide as ours. Like, for example, if this thing is, 8 inches across, then why do we need to have the chamber that opens up like it does to be 24 inches across?
Good point.
And I was thinking of the mini Epiphyte that Alex built, kind of as a demonstration.
Yeah.
Looks like PVC pipe. Maybe this thing could be a plug kind of in the middle of a PVC pipe.
So almost just like a long cylinder would be the sort of heart of it, with a fan on the one side, and almost exactly like what Alex has. You mean?
Yeah. Like I can imagine it like a catalytic converter, although I don't know really what's in them, but they're not that wide.
Yeah. Yeah. What was the reason when we did the again? I was almost shocked when I walked into, we had Octavia made theirs, and then I walked into Clarity, and they had this very similar design. I mean, I'll show you a picture if they can share with me that really almost looks exactly like ours. So there must be, I guess, some sort of reason why having that sort of bulb at the middle is a feature of these kinds of things that maybe you don't get if you just have a sort of a PVC pipe. I don't know. I can't remember what the original design was.
I think it was only that the original thought was that the sorbent panel would also be the same size as where it opens up to like 24 inches square, which is what they did with Thursday. But we made ours smaller just so we wouldn't have to buy as much sorbent.
Right.
Yeah, I think it's all about the surface area of the sorbent and how you get the airflow through it. So one way is to have it big and thin, and then the other way would be to have this monolith idea where it's long, smaller.
Yeah.
Yeah, I'm sure there are all kinds of engineering trade-offs that have to do with airflow and stuff that I don't know that much about. But the only reason that if we're only going to have as a final build an 8-inch square sorbent panel, for example, then there's no reason at all to make that chamber any bigger than 8 inches. It was just, 24 inches was something we found off the shelf, and it gave us the flexibility to be able to have a 24-inch square panel, which we never ended up using, partly just because it would cost, it would require 9 times as much sorbent material.
Yeah. Well, do you think also, I mean, that one brick that I showed you, I don't know if it's that one brick. I guess it's a matter of how much sorbent do we want to have, and it's possible you take 4 of those bricks and make a bigger cube. You know what I mean? You might want that bulb in the middle there to be able to just fit more. You see what I'm saying? I don't know if it's a one brick type of thing that would fit into PVC. We might need to put more in a cube.
I think it's a question of how dense is the sorbent after the wash coat, right? How much sorbent are we getting on one of those monoliths?
Yeah, and he said he could help us think that through. The other thing he said, a bit of not exactly back to the drawing board, because I think they can probably give us recommendations, but the probably needing another type of sorbent, because to do that process, you have to heat the sorbent up to a certain degree that probably goes beyond the 100 C or so that's safe for the Luatit. But he recommended a couple of other, at least families of it, where he thought that, let me see what he wrote. He said, as far as sorbents goes, polymeric amines like PEI work great with this process, alkylate, carbonates, and even zeolites and MOFs, I think. So, but he might be able to recommend if we say we want to go down this road. And I shared it with Ben Evans as well in Paris, and he texted me back. He would look at his notes and see if there's anything else, but there's got to be something out there we'll probably get on Sigma.
So one thing I don't really have my head around is that wash coat process, and is this something that distributed teams are going to be able to do without a lab, let's say?
Yeah, I asked them that, and I was also in their space, and their lab is quite small, and she doesn't have a lot of stuff, and so he again could walk us through that. But he thought if we use our sort of assumed environment for this to be university labs, I can't imagine that the university the typical university lab is any less well equipped than what they have in theirs. And he said he didn't need to use like, I was joking with him, like, do you need a hazmat suit or anything? You know what I mean? It sounded like it was the kind of thing that he does a whole bunch of monoliths like every week. He's like constantly doing these processes. And so he pointed to like a jug of one chemical for the wash coat and kind of talked me through the process a little bit, but he does it all in this one corner of the lab, which is mostly for mechanical engineering stuff. So again, the point we have to sort of figure out, but it didn't strike me as something that is extremely high tech or a limiting factor if we're assuming university teams. And
but
then
does it tie us to university? Like is someone going to build one in their garage?
I don't know. We can find out. I think talking to those guys, they were definitely like, oh yeah, that the way you're doing it by just kind of dumping in the sorbent there, like definitely, you'll need to make a change on it. So if we can find, as we know well already, but if we have to find some other kind of approach, and balancing between a garage and a lab, I could certainly take a university lab as the threshold for it. I think that would be pretty prolific, but I don't know. What do you guys think? And we have to find out. Who knows? Maybe it is something you could do in a garage. But do you think it looks too sophisticated or something that it starts to sort of shrink the pool of involvement?
I think I don't know.
What's that, Ling?
I don't know enough to say.
Yeah. We need to find out more.
I mean, if the process is that simple, then maybe we have a central facility, right? If it's $12 for the ceramic and the wash coat process is another $5, whatever, right? If the whole thing is under $20, then just buy it from us. So
I like that idea. Yeah. I mean, again, we really do want to. He was very generous with his information. None of this is they're very cool technology, and I won't talk through what their secret sauce is, but this seems to be relatively industry standard, like a process that is not something that's protected. So he's not available at this particular time. They have a team meeting every Monday at this very moment, but he is on our Discord, and I'm sure we can at another time get him get some more specific for sure. But he also mentioned that he just stupidly through ChatGPT was just sort of looking up a bunch of various things about how you might uniformly heat a ceramic cube like that, and came up with silicone rubber pads that could maybe wrap around. And then when I asked Kirsch, he said that they use a resistive heater that heats up, and I saw it. It's like a real flat, little sort of squirrely, curly thing. One of the ones that goes like this. And he said we use resistive heater that heats up the inlet airstream before it reaches the sample. And we have a thermocouple measuring the air temp before the sample and a PID controller to turn the heater on and off and regulate the temperature. So does that sound coherent to you guys? Or?
Normal.
So I don't know. We'd have to more ideas on what that would look like. But any sort of looking at where we are with UPenn, which will absolutely be a partner, but we want to be able to proceed a little quicker, and because we just did secure some funding for an additional build to be able to build one at UT Austin, where I'm based with the UT team. We will want to explore this further, but it sounds like potentially an approach we could do for that build, and sort of redesign the chamber to work for them. But anyway, that's as far as I can take it, but wanted to just socialize it with you guys to see if you agree that it looks like it's worth pursuing.
Definitely.
Okay. I also want to show this. So do we think, though, let's say we do go with this, David, because we have the question of how many of those cubes do we want to fit in there? Does that sort of force us into a more bulbous kind of center there, right? Rather than a tube?
I think we should toss those.
We should what?
toss this. I think we should toss the 80/20 frame.
Oh, toss the 80/20 frame. Okay.
Yeah, because it restricts us into this form factor, and I think it doesn't even need to be like. Can you go back to the duct picture?
The cube.
No, the duct. Because it looks like the honeycomb structure, you can get it in any shape. So can you go back to the air duct, the AC thing? Yeah, this. So because like there's an opening on the side, we can get like thinner ones, and then we can make a stand for it on the inside, and just put sheets of the honeycomb structures inside. And it may not be like 24 by 24, because I think if it's that tall, then you wouldn't be able to fit as many inside. But because it's completely hollow and air is able to go through it, it doesn't matter that it doesn't fill the entire foot cross section area.
Yeah.
Does that make sense to you guys, David and Seth?
I think so. Are you saying that we can still use the same box, the same?
Yeah, we don't
filter?
have to. We don't have to, but I don't think we should hang on to the 80/20 just because we have it.
I agree. That was meant for flexibility,
Yeah.
and it turns out it had its own problems.
Mm-hmm.
Do you guys think you could do something like? Let me show the full one here. So if we got rid of the part, the square part, right, that we slide the chamber into, and just had the other parts. And I wonder, as I was saying, if you had like a hinge on one side, so when you open it up, you could almost at a 90-degree angle open up the one side and then put the square in and put it out. And then, as Ling was saying, it almost would just perch on a stand. It would just be sort of in space, right, with some kind of heating element below it, or however we do that. But just like kind of closing the gap here, so we don't have this thing any longer. Was that what you're thinking, Ling?
Well, we make a stand that can be inserted inside, but honestly, maybe David's idea is better. It's like about using just a PVC pipe. I just think that we should go with something that's more square. That way you can make a door for it more easily.
Yeah.
I think round structures are difficult to work with, and I don't know if it's as aerodynamic to use a square, but I don't think it matters too much, because most of the monolith will still get the airflow. Sorry, Seth, what were we thinking?
No, sorry. I don't know. It feels like the PVC pipe approach is really promising. I mean, if it's literally made out of PVC, I just screw the two ends together.
Oh, okay. Yeah,
right?
yeah.
And that's where the monolith sits. So I can just unscrew one end, pull it out, swap it in.
Yep.
Well, like
Just
a
push it
threaded
into one of the
PVC?
ends.
Yeah, exactly.
Okay. How thick, how wide of a PVC could we get, though?
I mean, it doesn't have to be PVC. It's just a concept, but threaded pipe is the idea.
Yeah. Yeah, that's a cool idea. I am curious, though, just looking up. I mean, obviously using stuff like PVC is great. Just in your own experience, I'm curious, what is like your, I mean, one thing I guess you could potentially do too is you could have bricks that are sort of in, horizontally, if you wanted to, if the airflow is really not restricted at all. I don't know what that would do with the heating, though. I guess you kind of want it all bunched together so that whatever your heat source is can uniformly heat up the brick. And if you put them side by side, you'd have to, I guess, have, I don't know how you do the heating, but
I mean, you could imagine a modular system where I've got a section, right? I've got one fan section, and then I've got any number of sections that have threads on both ends, have a male and female thread with a heating element and a stand.
Yeah.
right? So I could do it with a single monolith, or I could tack on another, and each one's got its own heating element in series.
Yeah.
Mhm.
I like it. I'm just looking at some funny images here of really big PVC pipes. So it looks like there's quite a few options here, ones that are being lifted up with a crane. So
You can get it up to 24 inches diameter on McMaster. You can do like 8, 10, 12, 18, 24.
mhm.
Well, that's expensive.
How much is it?
I just randomly saw this one, 16-inch diameter, a 5-foot section is $507 from somebody. PVC fittings online.
What was that, 16-inch you said?
16-inch outer diameter, 5-foot length, $507.
Hmm.
How much was all the ductwork in the current Epiphyte?
It was probably,
Um,
I mean, there's a lot of stuff there we had. We had to do the actual custom sorbent chamber making. We had the 2 other pieces. I don't know. I'll have to look at exactly what we paid. It's probably not too wildly off from that.
Yeah, I don't think the duct was that expensive.
Yeah.
I don't remember how much.
The other thing that's cool is these come in circular form, actually. It'd be interesting to see if you could have one that, again, there's many options, it appears, with how these can actually be configured. So
Our filter box was $250.
mhm.
The fan was $270. And we had to buy dampers.
Yeah, there's a lot of other stuff. too.
$250.
mm,
The sorbent chamber, of course, not free either. We wouldn't have to worry about it as much.
I'm also kind of thinking it'd be interesting if there was almost like a comb type of shape, right? So almost like a module, right? Like with a solar panel where you could build an array where you have one QVC with a sorbent brick in it and a fan is one module. But you could imagine where you had like a circle with a brace or something where you're fitting in different PVC pipes, each with their own, I don't know. It just seems like a way you could possibly build an array if you created something as simple as a PVC pipe with sorbent in it on a fan on one side with dampers,
Sorry, I didn't understand.
Meaning if you have if you imagine, just using solar or battery talk, you add panels together in series and that gives you an array. That if you look at the simplicity of what we're talking about here, a tube with a fan on it, with a heating element inside of it, it's very minimal, right? So one of those could be one for a certain amount. But if you had a sort of a structure that if you imagined almost like a circular structure that itself is like a comb, where you could slide in different PVC pipes and you do 10 of those pipes is an array, but it's all built into sort of one system, could be interesting. I don't know what that would do with sensors and stuff because, if we embed each pipe has everything you'd need, or if you had a bunch of them, they would all link up to, I don't know, just spitballing here. But I like the pipe idea. It's certainly accessible. So I guess we have a lot. What are your top questions that we need to ask Kirsch and others? And obviously we want to get Alex pulled in on this. But curious when you think of next steps, like some key questions we need answers to.
So it would be what would be the I don't know what the term is, but as far as airflow, what would be the resistance of one of these kind of devices? How much does it block the airflow, which would determine what kind of fans we need, how fast the air could go through.
Mm-hmm.
Also, what kind of thermal characteristics does it have? So if we wanted to heat the sorbent, how well does the heat spread to the different sections of it? And then what kind of sorbents could be deposited this way?
Yeah. I know in terms of the ceramic itself, obviously has amazing heat tolerance. It's over 1,000 degrees C when I looked it up, and I think that's why they use it. But yeah, we'll need a lot more guidance on that.
I
But
don't think we should be using conductive heating in that case. It looks like most likely there will be minimal air resistance, like air can just flow through the grids.
yeah,
So in that sense, it doesn't make sense to use like heated wires. It'd be better to use like radiative or convective heating. I I think I'm more curious about um, I'm more curious about the process. I think it's because I'm a process person, but it's linked to David's question that like what kind of sorbent can be used.
yeah. This was the one that he gave us. Again, I can ask him to elaborate, but he mentioned some basic families. Polymeric amines. Again, I don't. I'm not. I know what means are, but what exactly that means? Alkali carbonates and MOFs were what he suggested. Does anybody know what an alkali carbonate is? None of us are chemists, three people here, but
I know nothing specific about chemicals, but I think what I'm after, I treat like unfortunately I treat biology and chemistry similarly. Like I just can't spend the time to understand each and every chemical or biomarker like in very that much detail. So it'd be better to understand what the process looks like, and then we will know if we're given a new chemical, if we can apply it to the surface of the structure. Like it let's say that we can use a few of these sorbents. So what does the process look like? What do these sorbents look like that allow the process to get the sorbents to adsorb? I think the term is adsorb onto the structure. And if we understand that, then we know what to look for in the sorbent to get it to adsorb onto the structure. We don't have to be limited by their list of sorbents that I know nothing about. All sorbents ever.
Yeah. Okay. Would you guys also be open to maybe next week meeting at a slightly different time if it meant we could get Kirsch and the UT team on the call? I agree with Len. Yeah. And Len, you were right like a while back. Like if we're building it at UT with this team, we want them on now, not in August when I get back to Austin. So if you guys are up to it, we can change the time of this to work for those guys.
Yep.
Yeah, I may not be available at all next Monday, but in general, I'm pretty flexible about the time.
Okay. Seth, you as well?
No, I'm not available Monday.
Okay. I mean, I'm even open to not being on Mondays, like whenever is good for people, but later in the day maybe.
I'm open to on other days, but my days can get busy, so it'll be best if you can provide a few time slots.
Yeah, I'll put out a little when to meet and see when people are available. So I'll share that. I just shared the just one article I found on alkali carbonates, and I've had good. It's amazing when you upload it to a chat bot or an LLM like the one that we have, and ask it very elemental questions. It's able to make it at least clear. It's not always right, but I've been able to adjust for my 11th grade science education. It's been helpful for me to get to this point. So there was also in the Canva I shared with you guys, which I can actually go ahead and make public. I did a little WhatsApp dialogue around wash coding and stuff like that. And then I shared it back with Kirsch, and he was like, kind of like, wow, I can't believe you got that from ChatGPT. It was quite correct, I guess. So if you guys saw that, that would be, there's some pretty good stuff in there. It kind of at least tells us like what kind of process is involved in wash coding, and how does that line up with what, that it's like how significant and sophisticated of equipment do you need? What are the safety issues? I'll just pop that in the chat there, that anybody can look at it and comment. So,
Okay.
all right. Any other sparks of lightning or thoughts about anything related to this or more broadly about the project? All right, I'll take that as a thoughtful silence. So we can share that on the Discord, and we can also ask Kirsch questions directly on there. He's in the channel for Epiphyte, so we could probably cover a lot of ground and specifics. But one other thing I'll point out is I made a couple of little, just some very minor adjustments to the digital deck where I front-ended. The GitHub is on the first page, the link to that, as well as the calendar for these meetups. So if anybody who's watching this hasn't yet looked at the Epiphyte brochure, which gives really good background on what we're trying to achieve, I just popped it in the comments there. So, all right, cool, guys. Please do join. Anybody who's watching this, there's a way to join our Discord right in that document that I just shared. So, would be great if you're not already in our Discord. We can lead you into the channel where we talk about this stuff in between Monday meetings. So it's absolutely the more the merrier. But leaving here, we're very much open to the idea of threaded PDC and a honeycomb monolith. And that may or may not be, with some more information, the direction that we take by the time we get to Austin. So to be continued, but that seems to be a possibility. So,
Okay.
Sound good, David?
Yep, sounds great.
All right, cool. All right, guys, we can go early if nobody has anything else to share. But anyway, big potential turn to the corner. But and we'll obviously. I'm sure, again, having UPenn as a partner on this is really key. It'll just take a little bit more steps and time, but we'll proceed with UT. All right, folks. Talk to you in the Discord, and see you next week for those streaming in.
Okay.
See ya.
Bye.